Now, we continue looking into what is software product quality. For software product quality, many definitions over the years have been made. In this lecture, we will follow the most recent definition of software product quality given by ISO 2500101. This standard defines software product quality through 8 software product quality attributes, namely functional suitability, performance efficiency, compatibility, usability, reliability, security, maintainability, and portability. If we take out the functional suitability software product quality attribute, then these remaining 7 quality attributes are sometimes referred to as non-functional requirements. This is because they describe properties of software that are not related to the functionality of the software, but rather something beyond these functionalities. And the term non-functional requirements would be especially dominant in the requirements engineering field. Now we go over the software product quality attributes. Starting out by functional suitability, we can state that it describes the functionalities of the software. The sub-properties that are defined are the functional completeness, functional correctness, and functional appropriateness. In the screen and in my hand, I have 2 Swiss Army knives. We can see that clearly the thicker Swiss Army knife has more functionalities. Therefore, we could say that it has better functional completeness. In terms of functional correctness, they are likely to be the same. Whether the functionality, everything is appropriate, this is to a certain degree up to the user. If we go with the scalars example, or the scales that we saw in the first videos, I would guess I have to pick the winner to be the smaller scale. It has more features. It can do imperial and metric units. The other scale cannot, because I don't have the ways to do imperial units. And also the results seem to be a bit more accurate, although I don't actually have a standard to compare it with. But I'm thinking in terms of functional suitability, the smaller scale has a slight advantage. Next software product quality attribute according to ISO is performance efficiency. This can be quite easily understood when we look at the task manager or some performance measures from a computer. So what we can see on the screen is a screenshot from my computer. This is Windows 10. So we can see the CPU load, we can see the memory, we can see disk performance, we can see Ethernet, and then we can see the graphical processing unit load. Now, if we think of software product quality or software product quality attributes, we can say that software that consumes less CPU power, less memory, less disk space, less network bandwidth, and so on, has better performance efficiency. Continuing with our running example with the scales, I think this is we cannot declare a clear winner, because if we consider the smaller scale, it uses more energy as it is battery powered. However, the larger scale consumes more space and it weighs more. So I cannot really say which would be more, would have better performance efficiency in this case. In terms of electricity, the larger one is better, but in terms of occupying space, that would be relevant in this case, I have to say that the smaller is far better. Next quality attribute is compatibility. In the screen, you can see some sockets and some plugs. We can have the USB cable, which obviously does not fit to the Shuko socket. So compatibility is the degree on which the software is compatible with other software. Compatibility also includes things like coexistence, which means that whether a particular software can exist with many other different kinds of software running in the same hardware or software environment. Again, I'm having a slight difficulty to declare which is the winner regarding the scales on the compatibility quality attribute. We should first declare compatibility with what? On one hand, the digital scale offers a numeric value that can be read directly from the screen. So placing a camera that would recognize the numbers would allow us to export the information to some other digital system. So in that sense, with regard reading the results, it would be easier to transport the results to some other system. On the other hand, I think compatibility is better with the old bigger scale, in a way that if you want to build some type of compatibility that depends on the physical properties of the scale, you could connect it to some other mechanical instrument perhaps, and in that regard, with regard to compatibility with other mechanical world, I think the old scale is better. The next quality attribute is usability. This includes things like appropriateness recognizability, which means whether the user can recognize the appropriate features and functionalities in the software. Learnability, which is how easy it is to learn to use the software. Operability, user error protection, which means how well is the user protected from making errors in the system, so that user doesn't actually delete all of his or her own files, for example. Protecting user from making actions that are most likely undesirable for the user. It includes also things like user interface aesthetics and accessibility. For example, people that don't see or see too well, so there is perhaps ability to zoom so that the buttons become larger and they are easier to see, and so on. In usability, it is also very important to recognize the different users, because depending on the user's capabilities, the usability can be widely different. For example, on the screen we see a cockpit of an old airplane. And if you are an expert air aviator, or what are those things called that fly the planes, then this might be actually quite usable to operate. But if you are just a regular guy from the street, then let's say from his or her viewpoint, the learnability of this user interface is probably not so great. So one would need to study hours to learn how to operate this. So always when considering usability, you should think, who is the user that you are designing the usability too. With the scalars example, it is quite easy to declare the smaller scale as the winner. It is much easier to weigh objects when you don't have to balance it with the counterweights as you have to do with the older scale. I would say this is even regardless of the user. So I couldn't really think of any user that would find the older scale easier to use. Maybe there is such a user, but for 99% of the users, I would say that the modern small scale is easier to use. The next software product quality attribute is reliability. It has sub-features of maturity, availability, fault tolerance, and recoverability. Basically, it communicates whether the software can be relied upon. I mean, perhaps we all have had a car that sometimes works and sometimes doesn't. If software sometimes works and sometimes does not, it is not very reliable. The reliability can be minor things. There is always some minor issue that doesn't work, or there is often some issue that's broken, or it can be major things like the entire system is down and all your data has been deleted. This is a major reliability issue. Okay, going back to the scales example. In terms of reliability, I'm thinking the old scale has a clear advantage. It has been functioning for past 80 years. It will still probably function at least 40 years. So it has a long history, and just based on physical inspection of the thing, it seems that it will have a long future as well. Whereas the older scale has maybe had a lifetime of 5 to 10 years up until this point. But if it survives the next 10 years, I would be quite surprised. Because these modern electronics are quite easily broken. Security is another software product quality attribute. All software should be secure to some degree at least. I mean, we have locks in our houses and locks in our bicycles so that they don't get stolen or robbed. We have police officers and security guards that ensure that criminals don't steal our stuff. Similarly, there are computer criminals that would take advantage of any security holes there exists, or even just persons willing to exceed their user rights and do something unintended. For example, a few years ago in Finland, the famous cross-country skier Mika Myllylä had died, and later it was revealed that the file that was in the police systems on the death had been viewed at least by 1,000 police officers. I wouldn't call these police officers criminals, but they were clearly curious on how the events took place that this Finnish celebrity died. And although they were not criminals, they were users that were exceeding their user rights because of curiosity. With the scales example, I'm declaring that the older scale is more secure. I'm simply basing this on the fact that it is more transparent. We can see where the results come from. We can more easily see that there is nothing hidden inside the system. For example, inside of those electronic systems, one could more easily hide, for example, a microphone, and one could use actually microphone because there is a battery in the electric scale, so it could be used to spy on people. Whereas for the older scale, it's more difficult. Of course, one could still put something inside there, but yeah, but I have to point out that the security quality attribute might not be very relevant for the scales. And this is something you should always keep in mind. How relevant is a particular software product quality attribute to the software that you are working on? As this will determine the amount of software quality assurance activities you are willing to do in order to ensure the particular quality attribute. So for some software, security would be the top quality requirement. For others, it might not be so important. The next software quality attribute is maintainability. It has sub-features of modularity, reusability, analyzability, modifiability, and testability. In the screen, you can see a picture of me from maybe 15 years ago. I was working on maintaining and further developing a piece of software that was developed at the university as a research prototype. Not all the pieces of the software were maintainable. For example, I discovered this very long method with over 500 lines of code and with cyclomatic complexity of over 100. Maintaining or making modifications to this method was completely impossible. So maintainability takes a viewpoint of the software that is looking at the internals of the software. So the previous quality attributes mainly focus the viewpoint of to the software from the outside, but maintainability highlights the developers or software engineers' viewpoint to the software. Coming back to the scales example, I have to say that the older scale is far more maintainable. So, shall there ever be a thing that needs to be fixed in the scale, it will be much easier to fix on the old scale, because it's quite easy to analyze where the problem might lie from a physical system, whereas for the electronic scale it would require much more knowledge of the electronics of the system and also some specialized instruments to figure out where is the problem. The final quality attribute according to the ISO standard is portability. It has sub-attributes of adaptability, installability, and replaceability. A great example of portability is the Linux operating system, represented by the penguin on the screen. We all know that Linux is being used in mobile phones, different types of servers. It's also used in high-performance computing environments that have these supercomputers. It's also used in various network devices and so on. So we can state that the Linux operating system is highly portable to these different environments. Continuing with the scales example, I'm calling this a tile. The smaller scale is more portable in the sense that it is smaller, so it could be ported to different environments. On the other hand, it would be easier to port the older scale as part of some other system because it's mechanical. Of course, it's a bit difficult to see how either of these scales could become part of some other system or that there would be need to port them to some other system. So again, having a bit of a difficulty on using the software product quality attributes to compare these physical objects. Testing. For 6 out of these 8 software product quality attributes, software testing is one of the main methods we ensure that these qualities are present. We have functional testing, we have performance testing, we have compatibility testing, we have usability testing, we have reliability testing, and we have security testing to ensure that the software product meets these qualities. Maintainability and portability are a bit different quality attributes. We really do not have maintainability testing or portability testing. Or we could, but it's not so relevant. Maintainability and portability are quality attributes that are built into the software, into the source code. So there would be more static methods to evaluate those quality attributes. However, quite interestingly, under maintainability, we have a quality attribute, testability. This means how easy it is to test the software. And this testability quality attribute obviously influences the software testing we are going to do, how easy it is to do, how much effort, how many euros we need to spend on it. And therefore, the testability quality attribute, as it influences testing, it also influences the testing of all these 6 other software product quality attributes. So it influences functional testing, performance testing, compatibility testing, usability testing, reliability testing, and security testing. I mean, maybe not so much on the usability testing side, as that is conducted typically with the main focus on the user, but for the other testing, the testability component of the or the testability quality attribute would be highly relevant.